This is question 3 of the 2020 Waves exam. Sweet as. Right, so we got Lily and Dave conducting an experiment to measure the frequency of sound produced by a car horn as it travels past a stationary observer. Lily drives her car from point A to B, directly past and very close to Dave, who is recording the frequency of the sound. Sweet. Very careful with this wording here. Very close to, so we don't have to use any trig whatsoever. Right, using the data recorded, Dave was able to plot the frequency he observed in the graph. I hope you can see that. Sweet. Using the graph, state the frequency Dave hears the car as it travels towards him. Dave hears as the car travels towards him. Sweet. So he's going to hear 900 because, I mean, assuming this is, yeah, he's going to hear the higher frequency, 900. Alright, so that was easy. Why do I still do those stupid things in the Z? I got that from math lecturers that used to put dashes in their Z's. I suppose it's to differentiate between 7, but it's a bad habit. Well, not a bad habit. Anyway, by considering the motion of the sound waves from the car horn, give a reason why Dave's meter detects a change in frequency as the car approaches him and then goes past him. What? How much space have I got? Oh, okay, I got a bit more space. Okay, there's no little. Okay, cool, right. And they're just asking why this graph exists. So as this is just straight up how to explain Doppler. As the car's moving towards Dave, the car catches up on each emitted wave, thus decreasing the observed wavelength for a stationary observer. And then as the car moves away from Dave, it moves away from each emitted wave, giving an apparent lengthening of the wavelength. Yeah, I forgot about that apparent lengthening. Yeah, right, I'll pause that and write it out. All right, so I said as the car approaches Dave, each wave emitted from the horn is closer to the previously emitted wave as it is moving towards the emitted waves. Full stop. This capital letter. This causes an observed shortening of the wavelength and thus an increase in frequency. Man, I am messy. When it moves away, each wave is produced. When it moves away, each wave is produced further from the previous. I've run out of space here, increasing the wavelength and thus the observed F. This is a diabolical question. Whoever wrote this question, when you write, I've already written. Oh, yeah. Anyway, regardless, I've had to write exams. You should only really do. It doesn't matter. You should really only do the first part and not do the away from him part because it runs out of space, and you're just answering. Well, the kids, if they know how it works the one way, they certainly know how it works the other way. Anyway, using the information from the previous page, calculate the constant speed of the car that Lily is driving. Sweet. So we have two observed frequencies. So we're going to have, this is just like it's not a simultaneous equation. You got F dash 900 and we have F dash, what's the other one? 800. You've got the formula, F dash is equal to the actual frequency times I actually don't have the formula sheet, so I'm going to have to figure it out. The wave speed divided by the wave speed plus or minus the wave's source speed. Sweet. So we have to rearrange this diabolical question, and then we have to use some intuition to figure out what goes where and how goes what. So I'll just flip everything. I'm going to move this F to one side. If I move this F to one side, it'll be 1 over F. So I'll divide both sides by the actual frequency, and then and the parent frequency. Then I'll just flip everything. So I'm going to have F is equal to F dash VW plus or minus VS over VW. I mean, you can use that as you can figure that out, hopefully. Anyway, so I know they both have the same frequency because the car's just emitting the same frequency. So now I can equate two equations together. So I would have F dash what is it? VW plus VS over What am I even trying to find? I'm trying to find VS, aren't I? Over VW. And I'm going to have that. It's going to be equal to F dash VW minus VS over VW. And you can see obviously I can cancel both VWs from both sides. It's going to make things a little bit easier. So I end up having, and this is, I can put brackets around this because it's times by the whole thing. So I'm going to end up with, and I'm not going to substitute it until the very end. If that, so I'll just keep a little side note for this formula here. If I'm adding, so okay, let's just go back to here because I need to explain how I know what to do with the 900 and the 800. That should be equal. If you are adding, so if it's plus, this would make the denominator bigger than the numerator, which would mean f dash would be smaller. So I know that f dash low is associated with plus. So if this is just how I'm going to figure it out, so I can keep tabs on things, and f dash minus is going to be high. I hope you can follow me with that, because I know you just look at the formula. You go, if I know, let's assume this is 850. If this is to be bigger than that, the denominator needs to be smaller. So it'd be minus. So that means if I went VW minus VS, I would expect this to be 900. So if this is 900, I know that this has to be minus. So minus, the frequency is going to be high, and this is going to be FH. I hope you guys can follow that along. Right. I'm going to pause this to figure out. I think this is going to be the hard way to do it. Yeah, I figured out an easy way to do it. I just messed up a minus sign. Right, so we're going to have, this is low VW, and I'm going to times this out. So this is going to be plus F low, let's dash up there, VS is equal to FH dash VW minus F H dash VS. And what I'm going to do now is I'm going to shift all the VS's to one, or everything that's got a factor of VS to one side, and then into the other side. So I'm going to have down here F low dash VW minus F high dash VW, wave speed. And that is going to be equal to minus F low dash VS minus F H dash VS, and then pull the factor of VS out of here. So you'd have, this is equal to, brackets minus F dash minus VFH dash VS. I mean, this is diabolical. Right, so now you can see that this here is equal to this. So if I get this and divide it by just this part here, I'll get VS. So I'm going to have VS is equal to FL dash VW minus FH dash VW divided by, this is what screwed me over when I tried to do this on paper, minus FL. I didn't pick up that minus sign, and I was like, what is going on? Minus F dash, I knew I was doing it correctly, dash, there you go. And that is going to be equal to, the lowest frequency is 800 times 340 minus 900 times 340 divided by minus 900 minus 800, and that does totally equal, I just did it before, 20 meters per second -1. There we go. Right. That's a diabolical question. After Lily passes point B, she decides to accelerate away from Dave, who remains in the same position. Use your knowledge of the Doppler effect. Explain how and why the frequency that Dave hears changes during the time. So she's increasing her speed, so she's increasing the separation between the waves. Thus, she's going to decrease this frequency Dave would hear even more because the wavelength is increasing. That's it. Right, I'll pause right. Right, so I said as she accelerates the wave, the distance between each emitted wave will increase, thus increasing the wavelength continuously. I was trying to explain that it wasn't just one increase, it was just continually they're getting further and further apart. Thus, Dave will hear that frequency decrease as she accelerates away. I should decrease continuously as well. Continuously. I don't know how to spell that, but anyway. Thus, that is all.